Hey guys, I'm Sayan Gupta and I'm 10 years old. I'm the founder of tennisforthekids.com. And if you like this video, don't forget to smash that like button and share this video with as many people as you can. And if you have not subscribed to my channel yet, so do it and press that notification bell too so that you don't miss any of my JavaScript or Python videos. So without any delay, let's get started. Okay, so today we are going to talk about Bitwise. So today we are going to talk about Bitwise. This is quite cool. This is really cool. Okay, so here we have JavaScript Bitwise operators. Our first operator is and it sets each bit to 1 if both the bits are 1. Okay, so we have now the operator or. Okay, sets each bit to 1 if one of the two bits is 1. So okay, so now we have XOR. So it sets each bit to 1 if only one of the two bits is 1. So these are quite similar. So let me tell you the difference in between them. So like in OR, if we have 1 and 0, so it will be 1. If we have 0 and 1, it will be 1. In OR, if we have 1 and 1, then it will be 1. And if we have 0 and 0, then only it will be 0. But in XOR, if we have 1 and 1, then it will set it to 0. If we have 0 and 1, then only it will be 1, or 1 and 0, then only it will be 1. Okay, and 0 0 will of course be 0. Okay, so next we have NOT, inverts all the bits. Now we have 0 fill left shift. Shift left by pushing zeros in from the right and let the leftmost bits fall off. So like if we have a binary number 1010, so it will shift it left, so it will be 010 and it will add a 0 in the back, so it will be 0100. So for example, here it is giving an example like 5 and 1. Okay, so let's see this. So it is 0101, so it will shift it left. So it will shift it left, so it will remove this, so it will be 101 left, and now in the end it will add 0 as it said in the definition. Next we have sign right shift. So sign right shifts right by pushing copies of the leftmost bit in from the left and let the rightmost bits fall off. So let's see what does this mean. So like here we have 5 and 1, so 0101 and 1. So it will push it right, so it will remove this. Okay, so it will remove this bit over here, and then it will add another 0 because the first number, so the leftmost number is 0. The leftmost bit is 0. So first it will remove this. It will shift right, and then the leftmost bit is 0. That's why it will put 0 over here. So it will end up resulting 0 0 1 0. Next our final operator is 0 fill right shift. So the final operator that we will learn today is 0 fill right shift. So 0 fill right shift shifts right by pushing zeros in from the left and let the rightmost bits fall off. So for instance, here in signed we did 0101, and here came another 0. If this would be 1, if this would have been 1, then a 1 would be added instead of 0. So here it will be 1. Here it could be 1110. Okay, and down over here it will do. So if here it was 1, it will first shift left, so 110 will be remaining, and then it will add a 0. It will not see what is the leftmost digit, it will just add in 0. Okay, so this is the difference between So we have just completed JavaScript bitwise operators. Now we have completed examples also, and now we are on JavaScript uses 32 bits bitwise operands. So let's see what is this. JavaScript stores numbers as 64 bits floating point numbers, but all bitwise operations are performed on 32 bits binary numbers. Okay, so before a bitwise operation is performed, JavaScript converts numbers to 32 bits signed integers. So let's see, this is quite interesting. Let's read this once again. JavaScript stores numbers as 64 bits floating point numbers, okay? But all bitwise operations, I wanted to say operations only. So, but all bitwise operations are performed on 32 bits binary numbers, okay? So, before a bitwise operation is performed, JavaScript converts numbers to 32 bits signed integers. For example, here in the example, it was 0101 or 0001. So first, it will be these both numbers will be converted to 32 bit signed integers. After the bitwise operation is performed, the result is converted back to 64 bits JavaScript numbers. Okay. So when the operation is performed, it will be converted to 64 bits JavaScript numbers. So here is an important concept: signed. So signed numbers and unsigned numbers. In unsigned numbers, there are no negative values, but in signed numbers, there are negative values. So here we have three methods: signed magnitude, signed 1's complement, and signed 2's complement. Okay, so these days we use signed 2's complement, and JavaScript also uses signed 2's complement. So let's see what is this all. So these plus numbers, so there are 16 numbers here. Okay, so here till plus 0 they are all same. Okay, but from here just ignore this minus 0, like this is not so important for us right now. So this minus 1 till minus 7 are important. So like in signed magnitude, how do we calculate this? So let's see, how do we, if we have 1001, so how will we make out it is minus 1? So this, let's see, this first bit is for indicating that if it is a minus number or plus number. So in if it is 1, the first bit, then it is a minus number. If it is 0, then it is a plus number. So here it is a minus number, so here we have minus, and then 001. So how do we calculate this? So first in this bit we will do 1 into 2 to the power 0. Okay, so 1 into 2 to the power 0 will result, what will it be? So 1 into 2 to the power 0 is 1, and 1 into 1 is 1. Okay, so here this is 1. So 0, now we will do 0 into 2 to the power 1. So 2 to the power 1 is 2, and then if we multiply it by 0, then it will be 0. So now we will do 0 into 2 to the power 2. So 2 to the power 2 is 4, and 4 into 0 is 0. And this one we have to ignore because this is for minus or plus. So if now, like if we add these three results, so let's see, where should I show you? I don't have a blackboard. So like, let's just open the terminal right now. Oh man, mouse here. Oh, okay, so let's just open the terminal right now. And like if I write Python right now over here. Okay, so right now over here. Okay, so now we will do here, like if we have 1, let's take 1001, Okay, so here we have 1001. Then like we will do the first bit is for that for the sign. So here minus will come, so we will just, our number will remain 001. Okay, so 001, in 001 we will do 1 into 2 to 1 into 2 to the power 0, so it will be 1. Okay, so here we have 1. So the first bit, what should I say, like this is part of calculating it. So first we have 1, then if we multiply anything by 0, then it will end up as 0. So 0 into 2 to the power 1 and 0 into 2 to the power 2 will end up in 0. Then like we have 0 plus 0 plus 1. So 0 plus 0 plus 1 is 1. And then we added a minus sign before because there was 1. So this number in decimal is 1 minus 1. Okay, so I hope your concept is clear. Yeah, so I hope your concepts are clear of sign magnitude. How do we calculate it? Now we have sign 1's complement. Okay, so like how do we calculate a minus value in sign 1's complement? Let's see. So like if we have to calculate minus 1 in this, then we will see plus 1. Okay, that you can remember easily. So it is 0 0 0 1. So like we have to invert all the digits. So 0 will be 1 and 1 will be 0. So 1 1 1 0 will be minus 1 in sign 1's complement. Okay, okay, so this was quite easy. So let's see now sign 2's complement. So this is what JavaScript is using, sign 2's complement. Okay, so this is our main focus. Okay, so how do we calculate the sign 2's complement? So if we have to bring out minus 2, then we will have to calculate the minus 1 of sign 1's complement. So what is the minus 1? 1 1 1 0. Okay, this I told you how to calculate this. And then minus 2 will be 1 1 1 0. Okay, so like if we want to take out minus 1, then we have to calculate minus 0 in this. So plus 0 is 0 0 0 0. So minus 0 will be 1 1 1 1, and 1 1 1 1 is equals to minus 1. Instead of minus 0, it is minus 1 in sign 2's complement. Okay, so I hope you understood. Okay, so now here the examples above uses 4 bits unsigned binary numbers. So these are unsigned right now. Okay, because of this not 5 returns 10. So because of this not 5 returns 10. It would not have been returning 10 if these were signed. Okay, it would have been returning minus 6. Since JavaScript uses 32 bits signed integers, it will not return 10. It will return minus 6. Okay, so for making the binary number instead of 4 bits 32 bits, then we will add the same number that was our leftmost number. So it was 0 here in 5. So we are adding 0 about, I don't know how many times. Here we have 0 about 32, 29 times. So this is 29 times 0 and then 101. So this is 5. To make it 32 bits, we did it like this. So so if we invert this, so not 5 inverts, right? So if we invert this, then we will have this number 1 1 1 1 0 1 0. So not 5 is equals to minus 6. Yeah, so minus 6 we have here in 2's complement, as you saw, I told you that we are using 2's complement, and if we were using 1's complement, then here it would have been -5 instead of -6. But like whatever will be -5 in 1's complement, then that value will its value will be minus it. So like just see, like we are adding. So if -5, then -6. So like if -5 is 1010 in sign 1's complement, then -6 will be 1010 in sign 2's complement. So how do we calculate this? Let's see right now. Okay, so here we have like we will first take out -6 of sign 1's complement and then add 1 to it. So if we add 1 to sign 1's complement, then it will be 1010. So this was a quick method to learn that -5 is equal to -6, -4 in sign 1's complement is sign 2's complement -5. Okay, so this was a quick way, but the real way how we calculate is that in sign 1's complement, first we take out -6, then we add 1 to it, then -6 will be then we will have the result, the binary number, if we add 1 to it, and it will be -6. Okay, a signed integer uses the leftmost bit as the minus sign. Yes. Bitwise AND. So we saw this above also, but like if you want to, you can just pause the video and see the definition. So 1-bit example is 0 and 0. Its result will be 0. 0 and 1, it will be 0. 1 and 0, it will be 0. 1 and 1, it will be 1. Okay. So here we are doing this 1 1 1 1 and 0 0 0 0 is equal to 0 0 0 0. How we calculated this? This 0 is not equal to this 1. So 1 is so like 1 is not equal to 1 over here. So it will bring a 0. Like this, it is not equal. That's why. So here we have 1 1. So here we have 1, this 1. And this one matching, that's why it will 1 will come here, but these 3 digits don't match, that's why 0 will come here. So same for all. Now let's see bitwise OR. So 0 or 0, it will be 0. 0 or 1, it will be 1. 1 or 0, it will be 1. And 1 or 1, it will be 1. So here like 0 or 1. Okay, so 0 or 1 will be that 1. So like this here OR is coming, so 1 1 1 1. So like 1 or 1. So these are the same. So we wanted one of them to be the same, so one of them is same. So we are adding a 1 over here. So this is how we will calculate. I told all this up also over here, but like you want a type of revision. Okay, now let's see XOR. Okay, so 0 XOR 0, result will be 0. 0 XOR 1, XOR 1 will be 1. 1 XOR 0 will be 1, and 1 XOR 1 will be 0. Okay, so we saw that it should, 1 should not the first bit should not be 1 should not be equal to 1. So if the first bit is 1, then the second bit should also not be 1, so that you get 1. So like this example, it should not be like this. So like 1 XOR 1 is 0. Okay, so here we see here. Okay, so 0. Oh, sorry, my mouse was quite slowly. Yeah. So 0 XOR 1. This is okay. So these are all the same things. Okay. So 1 1. So here it is putting a 0 because 1 and 1 match. We don't want that. So like we don't want that that didn't make sense. Like 1 and 1 match, so it is 0. It is not on our wanting or not. So okay, so 1 and 1 is equal to 0. So here 1, this bit and this bit is 0. That's why there is 0 in the end. So here this is quite same for everything, every other this. Okay. Now we are on JavaScript Bitwise and. Okay. So, okay. Bitwise and returns 1 if both bits are 1. So we are now this thing is telling us triple times the same thing. So let's run an example. So run. So 5 and 1 is 1. Tell you how? Here. So in this chart, 5 and 1 is 1. How? Because 0, 1, 0, 1 and 0, 0, 0, 1. It will result 0, 0, 0, 1. How? So 1 and 1 match. So it will put a 1 here. 0 and 0 match. So it will put a 0 over here. 0 and 1 don't match, so it will put a 0 over here, and 0 and 0 match, that's why it will put a 0 over here. So its result is 1. So this binary number is 1, okay, in decimal. Okay, so now we are on JavaScript Bitwise OR. So we know what is this. So this is 32-bit number. These are 32 bit numbers. So this is an example. So it will give 5. So we saw this above. Okay. So 5 or 1, it will be 5. Because 1 and 1 match. So we want one of them matching. So here we have 1 added. 0 and 0. So it will of course be 0. 0 or 1, it will be 1. And 0 or 0, it will be 0. Okay. Okay, and here and we have done bitwise OR. Now we have to see XOR. So okay, so these are 32-bit numbers and all. So try it yourself. So 5 XOR 1 will be 4. Okay, 5 XOR 1. Let's see how. Okay. So 5 XOR 1. So here it will 4. So 0 1 0 1 XOR 0 0 0 1. So 1 and 1 match. So we will add 0. 0 and 0 match. So we will of course add 0. 0 and 1 don't match. So we will add 1. And 0 and 0 will match, so we will add a 0. So this number in decimal is 4. As simple as that. Okay, so we are now around XOR also, and now this is not. So here if we try this, it will be -6. If not 5, then -6. Okay, so I'm showing this to you again. Okay, so not 5. This is unsigned over here. So this is we want signed. So this was unsigned. So that example will not work. So this is -6. How? Because like we will invert all the digits. Okay, and that will be -6. Okay. So now we are here, JavaScript zero fill bitwise left shift. 1 minute, I'm just drinking a sip of water. Okay, so here's my bottle. That was good. Let me have one more sip. That was good. I have to talk so much. I got thirsty. Okay. So where were we? Yeah. JavaScript zero fill bitwise left shift. Okay. So this is a zero fill left shift, you know. So let's press this. Okay. So it is taking time. So how did we calculate this? So like, let's see above only here. Okay, so 0 for left shift, here it will be 10 because 0 1 0 1, and if we shift it left, so it will remove the 0. We will have 1 0 1 and it will add a 0 in, and that will result to 10. I hope you like, we did it before also, so you must be knowing that. So here we are in JavaScript sign. Once again, I'm just changing the color. I'm not comfortable with this color. Yeah. Okay. Now it is better. So we are on JavaScript sign preserving bitwise right shift. Okay, this is sign right shift. Bitwise sign right shift. So -5. -5 right, sign right shift 1 will result into -3. How did we do this? If there's an example similar to this, -5 sign. Okay, 1 minute. So we don't have a similar example. So let's see this. So first let's see what is -5. -5 is 1 0 1 1. Okay, and we sign right shifted by 1. Okay, so what does this mean? So like 1 0 1 1 is here, so it will remove 1, so we will have 1 0 1, and it will add an 1 in the end. So in the left, so the leftmost bit is 1, that's why it will add another 1, so our number will be 1 0 1 1. Sorry, 1 1 0 1, and 1 1 0 1 is -3. Yay! Okay, so -3. So JavaScript 0 fill right shift. So this will be, this is a 0 fill right shift, one of, okay, so we know, so this will be 2. So here in the example above, I can show this instead of going to the chart. Okay, so this is 2. Is this 2? So like, we will shift this right. So we will shift this right. So we will have 0 1 0 remaining, and then we will add a 0 because we will its name also tells us that it will fill a 0. So our number will be 0 0 1 0 here. Yes, we are getting grip of this. Hey hey hey. So this is a 32-bit number of 2. Okay, so it is showing 32 bits numbers of everything. So this is 2, and like, if you want the link for this, just copy it somewhere for this chart. Then I'm waiting for a few seconds. Till that time I will drink some water. This chart will come handy in your future life, maybe of coding. So if you want the link, check it, copy it. I will provide it in the description below too. Okay, so now we are on binary numbers. Binary numbers with only 1 bit set is easy to understand. So like, all here are 0 and we are adding a 1, so its decimal value will be 1. Here we have 0 and then we have 1 0, so it will be 2. Here we have zeros and it is 1 0 0, so it will be 4. Here we have zeros, so many zeros, and 1 0 0 0, it will be 8. And here we have zeros and 1 0 0 0 0, it will be 16. So here we have so many zeros and 5 zeros, it will be 32. And here we have so many zeros and 1 and then 6 zeros, it will be 64. Setting a few more bits reveal the binary pattern. Okay, so this is the binary pattern. Binary representation. This is the binary representation. It will be 5, 4 plus 1. Okay, then here we have 13. This is 13. 8 plus 4 plus 1. Here we have 45. 32 plus 8 plus 4 plus 1. Okay, so this is type of pattern. JavaScript binary numbers are stored in 2's complement format. I told you over here. This means that a negative number is the bitwise NOT of the number plus 1. So just leave this. I told you in a better way. So leave this stupid definition. I hate this definition. I'm starting to hate it. Okay, so here we have binary representation of 5. This is the binary representation of 5. This is the binary representation of -5. This is the binary representation of 6. This is the binary representation of -6. This is the binary representation of 40. And this is the binary representation of -40. So now we are on converting decimal to binary. So we are going to make a method that will convert a decimal number to a binary number and give it to you. So let's try it yourself. I will explain the code also. So here we are converting it. So like we are returning like des 0 fill right shift 0. So like it will if we have passed -5. Oh, what is this string connected and all? Yeah. So it will return des that we have passed here. 0 fill right shift 0 dot toString 2. So I'm going to explain this line. So do you see the power of JavaScript? Using one line, we returned the binary number of a decimal value. This is the power of JavaScript. This is a really useful language. That's why this is on the second rank. Okay, in languages. Here it is returning des 0 fill right shift 0. So let's see what is this doing. So first it will convert this -5 into a binary number. So here we saw here it wrote somewhere. I don't remember where did it write it. Okay, so yeah, before a bitwise operation is performed, JavaScript converts numbers to 32-bit signed integers. Okay, so it will convert -5 into this number first. Okay, then it will convert 0 into 32 zeros. Okay, and it will right shift by 0. So it will not right shift, and then when we have converted it, okay, so like you must be getting my point. So first it will convert des into this minus. So let's see, I want to show you one thing. I'm getting confused. So if we run this, so this is the value of this. So you see here that this is the value of this. So if command Z, so like this is the binary representation of this number. I should tell you how, because this is -5's representation, but that, what do we say, this, you must be thinking that -5, so these ones, I told you the method to the power that thing, and like when we do that method on this, then it will be that number that came after removing. So this is that number, and then when we do toString to 2, then it will be a binary number. This is a binary representation of -5. Okay. So I hope you must be understanding. You must be thinking, what is he making? What is he explaining? He's explaining so badly. I am feeling like leaving the video. But no, it is not like that. I'm getting quite thirsty. Don't think it as an excuse. And for this concept, this is quite like, I also at the first time understood it really like after a lot of time concentrating on it. So like it takes time. Okay, so I'm not able to say. So this is here, after combining both these, this and 0, 0, 0, 0, we have that number. So here if we remove this, so it by default will print it. So this is this number. Okay, so what should I say to you? Yeah, what should I say? I'm not able to explain, but like I'll try my best. So this will bring this number. Okay, so we are 0, will right shift in it by that. What we say? What do we say? 0. So we are not doing that. We by this is a method from which you can bring this number, this value that you want. Okay, so command Z and here 2. Okay, so we have this -5, and now we are converting binary to decimal. Okay, so here this is just bringing the magnitude. Okay, this is not really converting binary to decimal. This is only for like 101 is 5. This is for unsigned numbers. Okay, so 101 it will do % binary and comma 2. So comma 2 will treat it as a binary number. Okay, so I forgot to explain you one thing over here, that we have given toString 2. So toString 2 gives this number, so that 4 something will, if we do it toString 2, then it will represent it like a in the type of a binary number. Okay, so here we are returning % binary comma 2 dot toString 10. So we don't need this actually. This is just brain teasing thingy. So % binary 2. So this binary we pass this bin and bin comma 2. So this % will treat it as a binary number and will try to convert it to a decimal number. Okay, so like it will not take negative values. Okay, this is only for unsigned numbers. Okay, so I've just completed the chapter. Thank you guys. If you like the video, don't forget to smash that like button and share this video with as many people as you can. And if you have not subscribed to my channel yet, please do it so that you don't miss any of my JavaScript or Python videos. Thank you. Bye bye.